Hello everyone, welcome again on my YouTube channel Adadhyan's Tutorial Hub. Friends, in this video we are going to discuss about number systems, and this chapter is belong to mathematics of ninth standard. In this part 1, you will learn about the types of numbers and about rational numbers. How can we find more rational numbers between any two given rational numbers? So watch this video carefully. Students, in earlier classes you have already learned about type of numbers. These are natural numbers, whole numbers and integers. So we are going to just discuss about all these types of numbers in brief. First is natural number, and it is denoted by n. It starts from These natural numbers start from 1 and goes to infinite. Okay, so we can say all positive numbers are natural numbers. In other words, we can say all positive numbers are natural numbers. The next is whole numbers. It is represented by W. Okay, and it is the collection of 0 and all positive numbers. Means it starts from 0 and goes to infinite. So we can say 0 and we can say whole numbers are the collection of 0 and all positive numbers. And all positive numbers are natural number. So we can also represent it by 0 and n. So whole numbers are collection of 0 and natural number or positive numbers. Okay, so we can conclude that every natural number is a whole number. You can see these are natural numbers and all these are whole number also. Okay, but every whole number is not natural number because 0 is not a natural. So we can say every natural number is a whole number, but all whole numbers are not natural. Okay. Next is integers. It is represented by Z, and these are collection of positive, negative, and 0. Here they are positive numbers, okay, negative numbers, and 0. So we can say integers are collection of 0, positive and negative numbers. And positive numbers are natural numbers. Okay, we can say integers are collection of 0, natural numbers and negative numbers. 0 and n is represented by whole number. So we can say the collection of whole number and negative number is called integers. So we can say we can conclude some points like that. Every natural number is an integer. These are natural numbers from 1 to infinite, and it is a part of integer. So we can say every natural number is an integer. Similarly, every whole number is an integer from 0 to infinite. These are whole numbers. So we can say every whole number is an integer. The next type of number is rational numbers or fractions. We can say rational number or fractions. It is represented by Q, and it is defined as any number which can be represented in the form of P upon Q. Any number that can be represented in the form of P upon Q. Here P and Q both are integers, but Q cannot be 0. Okay. For example, 3 over 7, 5 over 6, 2 over 3, minus 4 over 5, and 1 over minus 2. So these are some examples of rational number or fractions. Here we can see rational numbers are the collection of integers, whole numbers, and natural numbers. How can we say that all integers, whole numbers, and natural numbers are rational numbers? Because any integer, suppose integers are positive, negative, and including 0. Okay, suppose -1 is an integer. We can represent it by -1 over 1. Here it is an example of rational number. Here P upon Q, we represented it the form of P upon Q. Okay, P upon Q. Here P is -1 and Q is 1. So it is a rational number and as well as an integer. Similarly, we can suppose 0 is a whole number and we can write it like this, 0 over 1. So now it is a rational number. And similarly, natural number can be represented the form of P upon Q, like 5. 5 is a natural number and it can be represented by 5 over 1. So it is also an example of rational number. So we can say all integers, whole numbers, and natural numbers are rational numbers. Okay, so here there are some conclusions. Every natural number is a rational number because rational number is collection of integers, whole numbers, and natural numbers. So all these numbers are rational numbers. So here these are 3 points. Every natural number, whole number, and integer is a rational number. Okay, students. Now another topic is equivalent rational numbers. Students, we know that any rational number whose numerator and denominator, when multiplied with the same integer, its value doesn't change. Okay, so these are called equivalent rational numbers. For example, 1 upon 2 is a rational number and you have to find its equivalent rational numbers. So we have to multiply its numerator and denominator with the same integer. For example, its equivalent rational number is 2 upon 4. How can we get this 2 upon 4? So we need to multiply 1 over 2 by 2 over 2. Here we will get 2 over 4. And now it is its equivalent rational number. Similarly, if we multiply 1 over 2 by 3 over 3, we will get 3 over 6. It is also an equivalent rational number of 1 over 2. If we multiply 1 over 2 by 4, we will get 4 over 8. It is also an equivalent rational number of 1 over 2. Similarly, we can find more equivalent rational number for 1 over 2, like 5 over 10 if we multiply its denominator and numerator by 5 over 5 and 25 over 50 and etc. and so on. You can find more and more equivalent rational number for any given rational number by multiplying with the same integer to its numerator and denominator. Okay, students. So next topic is finding rational numbers between two rational numbers. Suppose there are two rational numbers on number line and you have to find more rational numbers between them. You can find easily. There are some methods to find. One of them is by finding mean or average. In this method, we have to find mean or average for given rational number. Okay, for example, find three rational numbers between 1 over 2 and 2 over 3. Here there are two fractions, 1 over 2 and 2 over 3, and we have to find three rational numbers between them. So just find mean or average of 1 over 2 and 2 over 3. So just make a number line and mark 1 over 2 and 2 over 3 on this number line, and we have to find its first rational number between 1 over 2 and 2 over 3, and it will fall here. Okay, so find mean of 1 over 2 and 2 over 3 like this. 1 over 2 plus 2 over 3 divided by 2. It is the average or mean for both these fractions. Okay, solve these and you will get 7 upon 12. So 7 over 12 is a rational number falling between 1 over 2 and 2 over 3. Similarly, if you find mean of 1 over 2 and 7 over 12, you will get another rational number falling between both of them like this. Mean second. Here 1 over 2 plus 7 over 12. Both these fractions and find their mean divided by 2, and you will get the answer 13 upon 24. It will the next rational number falling between 1 over 2 and 2 over 3. And you can find again another rational number falling between 7 over 12 and 2 over 3 like this. This is called mean 3, and answer will be 45 upon 72. Okay, so it is also simplified by 5 over 8. Okay, you can divide both the numerator and denominator by 9. You will get 5 over 8. So its next rational number will be 5 over 8. So 13 over 24, 7 over 12 and 5 over 8, all these are three rational numbers falling between 1 over 2 and 2 over 3. Similarly, you can find more and more rational numbers. Suppose if you find mean of 1 over 2 and 13 over 24, you will get another rational number here. If you find mean of both these numbers, you will get another rational number here. Similarly, if we find the mean of all these fractions, we will get another rational number here. Okay, students, so we can say there are infinitely many rational numbers between any two given rational numbers. You can find more and more rational numbers between any two rational numbers. Okay, students, so it was method first, and we are going to see the next method. It is tricky method to find rational numbers between two rational numbers. For example, find three rational numbers between 1 over 2 and 2 over 3. The question is similar for all these methods, 1 over 2 and 2 over 3, and we will find the different numbers falling between them. So solution will be like that. You have to add its numerator and denominator, and first of all we draw a number line and mark both the fractions 1 over 2 and 2 over 3 like that. Okay, so first rational number between them, we represent it r1 by r1. Okay, so r1 will be find like that: 1 plus 2 over 2 plus 3. We add its numerator 1 and 2 and its denominator 2 and 3. Okay, and you will get 3 over 5. So it is the first rational number falling between them. Okay, similarly, if you find a rational number between 1 over 2 and 3 over 5, then now what will be added? 1 plus 3 over 2 plus 5. Okay, that will be r2, the next rational number. R2 will be find like that: 1 plus 3, 1 plus 3 and over 2 plus 5, 2 plus 5, and you will get 4 upon 7. It is the next rational number. Okay, similarly r3 can be find here. Just 3 plus 2 upon 5 plus 3. Okay, we will get 5 over 8. It is the next rational number. Okay, so it was a quick method. You can easily find many rational numbers. Suppose if you you want to find R4 here, just add 1 plus 4 and 2 plus 7. That is 5 upon 9. The next rational number between 1 over 2 and 4 upon 7 will be 5 over 9. Okay, you can find more and more like this. Okay, students. So we are going to see the next method third, and it is making same denominator. In this method, we convert both the rational numbers with same denominator. For example, find 5 rational numbers between 1 over 2 and 2 over 3. So first we have to write both the rational numbers with same denominator as 6. So just multiply the first rational number, that is 1 over 2, by 3 over 3, and 3 upon 6 is an equivalent rational number of 1 over 2. Okay, we have learned about equivalent rational numbers, and similarly 2 upon 3 will be multiplied by 2 over 2 and it will convert it into 4 over 6. 4 over 6 is an equivalent rational number of 2 over 3. You can see here there is no number between 3 and 4. If we write these numbers 3 over 6 and 4 over 6, so there is no number between 3 and 4. So we have to multiply these fractions again by another integer. So we have to multiply it by 10 over 10. Here we multiply 3 over 6 with 10 over 10, and we will get 30 over 60, another equivalent fraction of 1 over 2. Similarly, 2 over 3, whose equivalent fraction we have got 4 upon 6, is also multiplied by 10 over 10, and we will get 40 upon 60. So it is easy to find more fractions between 30 over 60 and 40 over 60. These are 31 over 60, 32 over 60, 33 over 60, 34 over 60, 35 over 60. You can find more. Here we have to find 5, but here you can find more rational numbers: 36 over 60, 37 over 60, 38 over 60, and 39 over 60. 40 over 60 is the number here. Okay, and 30 over 60 is here. So these are number that are falling between 30 over 60 and 40 over 60. You can write any 5 rational numbers. Okay, students, so this was the third method to find rational numbers between two rational numbers. I hope you have learned very well about all these 3 types of method. Okay, students, now we are going to solve exercise 1.1 of your first chapter. So first question is 0 a rational number? Can you write it in the form of P upon Q, where P and Q are integers and Q is not equal to 0? So you have already learned about that 0 is a rational number. So our answer is yes, 0 is a rational number, as we can write in the form of P over Q. For example, 0 over 2, 0 over minus 3, 0 over 7, etc. As you know, the final value of all these rational number is 0. So we can say 0 is a rational number. Next question 2 is find 6 rational numbers between 3 and 4. Here we can write 3 and 4 as rational numbers with same denominator as 6 plus 1. We have to find 6 rational numbers. So we can multiply both the numbers and with 7 over 7, that is 6 plus 1, like that. 3 equal to 3 into 7 over 7. You can write 3 over 1 also, and multiply it by 7 over 7, you will get 21 over 7. Similarly, when we multiply 4 with 7 over 7, we will get 28 over 7. Now you can, there are 6 rational number between 21 over 7 and 28 over 7. These are 22 over 7, 23 over 7, 24 over 7, 26 over 7, 27, 26 over 7, and 27 over 7. Okay, students. So these are fractions between 21 over 7 and 28 over 7, and 21 over 7 is a equivalent rational number of 3. So finally, these are the rational numbers between 3 and 4. Okay, students. Now next question, third, is find 5 rational numbers between 3 over 5 and 4 over 5. Here denominator for both the rational number are same, but there are no number between 3 and 4, so we have to multiply its numerator and denominator with another integer. So generally we multiply 10 over 10 and we will get 30 over 50. Okay, and when we multiply 4 over 5 by 10 over 10, we will get 40 over 50, and you can write 31 to 39 over 50. You can write 9. Okay, 9 rational numbers between both the rational numbers, but we have to only write 5 numbers. So you can write 31 over 50, 32, 33 over 50, 34 over 50, and 35 over 50. You can also write 36 over 50, 37 over 50, 38 over 50, and 39 over 50. Okay, and the last question is, state whether the following statements are true or false. Give reasons for your answers. So first statement is, every natural number is a whole number. Every natural number is a whole number because whole number is a collection of zero and natural numbers. Okay, so this statement is true, and reason is the collection of whole numbers contains all the natural numbers. Second statement is, every integer is a whole numbers. No, it is false. Because negative integers are not whole numbers. Negative integers like -3, -5, etc. These cannot be whole numbers. And third statement is, every rational number is a whole number. Is again false, because rational numbers like 1 over 2, 3 over 5, -5 over 7, these are not whole numbers, these are fractions. So this statement is false. So students, I hope you have understood everything whatever I have discussed in this video. So if you like this video, please comment and subscribe the channel if you have not subscribed it yet. Keep watching Aradhyan's Tutorial Hub.